Hi Nat5, so we are still looking at proteins and enzymes, and now the concept of optimum conditions, which is really important for how enzymes function. So enzyme activity is going to be affected by anything which changes how well a protein is functioning, and proteins function in terms of their shape. So anything which damages their shape is going to damage their activity. So if you think of an egg white is mainly made of protein, albumin. So if you think about what happens to that egg white when you heat it, it is very different from how it started. And that's what's happening if you take enzymes out of where they were at the beginning. Okay, so the change of shape has a particular term, it's called denaturation. So as you take a protein and you change it from the natural shape it's formed into, it's called denaturing. If we change the shape, we change the lock. If we change the lock, the key can't fit anymore. Okay, so this is a particular shape that we need to look at in the graphs for temperature, and we're also going to look at pH. Temperature is an asymmetrical curve, and what that means is that we have this shape. Okay, so at the start, with low temperature, like right down here, you've got nothing happening. Okay, but as you increase the temperature, you get an increased activity. And that you should be like, well, yeah, okay, that makes sense because temperature is to do with how fast things are moving. So as you increase the temperature, things are moving around more often, and so they'll bang into each other. So you get more of the substrate hitting the enzyme. Okay, and then we reach this point at the top where you're like, that's actually perfect. It's the fastest that this is going. And it's called the optimum temperature. And in this case, we would be able to read it down and we'd be able to read off the temperature and go, that's the optimum temperature. Okay, now that temperature would be different for different enzymes. That's important to think of. So for us, obviously, our internal temperature, 37 degrees, that's what we want our optimum to be. But if you're a carrot, 37 degrees is probably not a great thing to have. So they will have a much lower optimum. After the optimum, we reach a point where the enzyme denatures. And this is this term here. So it's lost its shape. And when it loses its shape, it can't fit anymore. And so the activity drops and drops fast. And once you've done this, your enzyme is wrecked. So the only way you're going to recover from this is if you have basically more enzymes made. And this is why fevers can be really dangerous if they're there for very long. So as well as that optimum temperature, pH is a biggie. Okay, there are also things like how much enzyme you have, how much substrate you have, and they're kind of obvious. They're going to have a straight line kind of relationship. Surface area, so how much of the substrate is available for the enzyme, all of these things would be normal things you would look at for affecting activity. And pressure might as well, okay, because that could actually increase concentrations. And ions, because they can change how well enzymes work. Okay, so all of these have potential for affecting it. This is the one that you're going to need to know another graph for. Okay, when we take all of them together, then we can say that we found the enzyme's optimum conditions, everything about it that says this is the best thing. So our second graph is for pH, and we can do exactly the same thing you did for temperature. So you put pH along the bottom and then we take our activity up the side. What happens with this one is, though, we get symmetrical curves. Now this is for a kind of general enzyme, for what you would expect most enzymes to be sitting at, you know, kind of normal pH roughly, you know, that's pretty close to neutral, and either side of that it's not doing so well once you go further away. But we've got a couple of kind of really specific ones in here as well. So they can be different even inside us. So here's our pepsin. Our pepsin has a optimum pH here at 2.5. Now that is quite drastically down on where normal things are for us. But the stomach produces hydrochloric acid to help in digestion. So our pepsin, which is in the stomach, has to be okay down at 2.5. Your normal enzymes would be not working at all. They'd be denatured and they wouldn't be functioning. So for pepsin, its pH is 2.5 as an optimum, and its range, being very careful here, is 1 to 4. Okay, you're not going to be asked to do the calculation for this. You're going to be asked to give the two numbers. So I know that in maths that you would be saying that's a range of 3, but we're not wanting that kind of range. We're looking for from to. Okay, so this kind of normal enzyme that they've got running here is running from 2.5 to 13. Catalase, okay, this one here, is running with a range of 7 to 11 with an optimum pH, I would say, sitting here at 9. Okay, and the reason catalase has this high pH is actually a lot to do with where it is. It's in the liver. The liver produces the chemicals which neutralize our stomach acid when it comes out of our stomach. So the things which are in the liver have to work in slightly more alkaline conditions than the rest of the body. Okay, so that's it. That's everything to do with these ones. Make sure you're happy with the graphs and the shape of the curves. And just the last thought.